lecture 38, and we are discussing over integrals in polar coordinate system. In polar coordinate system, right? So how these integrals gonna work in the polar coordinate system? Suppose that we have a function defined on R, defined on region R, and that function is, let's say I missed that thing, let's say f r theta, right? Defined on region R, which is bounded by the rays theta is equal to alpha and theta is equal to beta, right? And by the continuous curves R is equal to G1 theta and R is equal to G2 theta, right? Suppose that there is G1 theta is positive, G2 theta is positive, and G1 theta is less than equal to G2 theta, and it is less than equal to further A for all values of theta lies between alpha and beta, right? So let's say, how things are looking like. तो ये तो वो सारी चीजें जो हमने ये डिस्कस करी कि ऐसा होना चाहिए वैसा होना चाहिए, लेकिन अब ये दिखेगा कैसे, मैं उस चीज के ऊपर आ रहा हूँ, ठीक है? तो अभी देखते हैं क्या है वो चीज. Yes, are you with me?
Yes, sir.
Yes, sir.
Okay. So what I'm saying is, let's say I have a region. This is your, let's say theta is equal to alpha, right? This is one ray, and this you have another ray, which is theta is equal to beta, right? So this is your alpha, and let's say this is your beta. So this is theta is equal to alpha ray, this is theta is equal to beta ray. Are you with me? यहां तक तो समझ आ रहा है?
Yes, sir.
बोलो. So अब हम क्या कर रहे हैं, हम इसे छोटे छोटे ग्रिड्स में बांट रहे हैं. ध्यान देते रहना, मैं जैसे कह रहा हूँ वैसे ध्यान देते रहना. अब ये छोटे छोटे ग्रिड्स कैसे हैं देखते रहना. And the grids are like this. Right. And next we have this thing. Is it fine? Can you see those grids?
Yes, sir.
Right. So let me pick that one grid over here. And we are filling this grid. तो जो हम इस ग्रिड के ऊपर बात कर रहे हैं वही हम सारे ग्रिड के ऊपर ऑलमोस्ट उसका जनरलाइजेशन ही इंप्लीमेंट होगा. ठीक है? Are you with me on this?
Yes, sir.
Yes, sir.
So there is one way looking at this thing. So I am making one curve over here, which I call it as, let's say, this curve, and this I call it as r is equal to g1 theta. And next, I have, let's say, some second curve, which is this, and I'm calling it as r is equal to g2 theta. Yeah, ठीक है? ऐसी ही होती है ना कर्व हमारे पास, जैसे r is equal to 1 minus cos theta, r is equal to 1 minus sin theta, इसी तरह से होती है ना?
Yes, sir.
Yes. अब एक बात बताओ जरा, अगर मैं इसमें इस रो के ऊपर, अगर मान लो मैं यहां से यहां के बीच में डेल्टा थीटा का इंक्रीमेंट करूं, तो ये वाली लाइन का रोटेशन क्या हो जाएगा? कैन एनीबडी टेल मी? ये लाइन रेड वाली क्या है? थीटा इज इक्वल टू अल्फा है ना?
सर अल्फा प्लस डेल्टा थीटा।
एग्जैक्टली। तो ये क्या बन जाएगा हमारे पास? थीटा इज इक्वल टू अल्फा प्लस डेल्टा थीटा हो जाएगा ना यहाँ पे।
Yes, sir.
अब डेल्टा थीटा का ही और रोटेशन किया मैंने, सो आई एम एडिंग डेल्टा थीटा अगेन, सो व्हाट आई एम गेटिंग, डेल्टा इज इक्वल टू अल्फा प्लस 2 डेल्टा थीटा। यस, यू आर विद मी?
Yes, sir.
Yes, sir.
Are you with me? Yes. And I make another rotation. So if I'm making a rotation towards the anti-clockwise side, of course I have a certain amount of rotation. So what I'm assuming is each time I'm rotating delta theta more than its previous rotation. So of course at this point of time, I'll get theta is equal to alpha plus 3 delta theta and so on. Yes. Is it right?
Yes, sir.
Okay. So now in another way, what I'm saying is, now here your r is 0. So let's say if I assume that I keep on adding delta r at each stage. So here my radius would be delta r. And if I make a bigger circle, I'm adding delta r again. So it becomes 2 delta r. So here it becomes 3 delta r and so on. Can I do this?
Yes, sir.
Yes, sir.
So what I'm saying is, I'm covering this kind of this semicircle by 2 ways. And what are these 2 ways? I'm adding angles and I'm changing those radii. So let's say I name this thing as, this whole region as Q, right? So let's say I call this region as Q. So now I'm adding that thing. So we cover Q by a grid of circular arcs and rays, right? And these rays are what? And we have already covered these rays, and these rays are of sort of pink color. That's what we have used over here. And these circular were greens, arcs. इसी तरह से cover किया ना हमने, right?
Yes, sir.
Yes. So we have covered with these arcs, and the arcs are extracted from circles centered at origin and having radii. How much? First was delta r, another was delta 2 delta r, 3 delta r, and so on. So since it is closed and bounded, so let me take it, let's say last one was m delta r. Okay. So we know that, so here if you have m equal radius, so you can say that each radius can be written as a upon n, because this whole length is assumed to be a. The whole radius is assumed to be a, yahan tak ka. Yes, you are with me? ये a है सारे का सारा, ठीक है? ये a क्यों है? क्योंकि जो अब मैं सारी चीजें साथ साथ क्लियर करता जाऊंगा जो मैंने पीछे लिखा है। क्यों? क्योंकि मैंने क्या बोला कि ये ज्यादा से ज्यादा कहां तक जा सकता है, ए तक जा सकता है, ये बोला ना मैंने।
Yes, sir.
Yes, are you with me? So here you can think that your r2 theta and r1 theta are lying between 0 to a. Yeah, is it fine? So can we write this relationship that delta r is equal to a by m? Yes, tell me. लिख सकते हैं?
Yes, sir.
जो किसी को अभी तक कुछ ना समझ आया हो तो अभी पूछ सकते हो. Anything if you want to ask. Yes. Everything is fine.
Sir, how we can write delta r equal to a upon m?
Okay. So see this. यहाँ पे मैंने m रेडियस काटे हैं. यहाँ पे ये पहला, ये दूसरा, ये तीसरा, ये चौथा, ये पांचवा एंड फाइनल ये mth. ठीक है. हर किसी की लेंथ सेम है और टोटल लेंथ a है, तो हर किसी की लेंथ किसके बराबर आ जाएगी? ये हर किसी हो गया ना. टोटल लेंथ अपॉन नंबर ऑफ चंक्स एंड नंबर ऑफ चंक्स इज लेट्स से m. So of course each length would be what? a by m.
Okay, sir.
समझ आ गया?
Yes, sir.
और कुछ? Anything? Is it fine now?
Yes, sir.
Okay. So should we move further? So similarly, it's a same kind of relationship can be told about angles as well. How? So now the rays are, starting ray was theta is equal to alpha, right? And another ray is what? Alpha plus delta theta. And the third was alpha plus 2 delta theta. So let's say if we keep on doing like this, and let's say we can reach somewhere alpha plus m dash time the delta theta, right? अब ऐसा तो होगा नहीं ना कि ऐसा होना तो जरूरी नहीं है ना कि रेडियस जितना इंक्रीमेंट किया है उतना ही अमाउंट में भी आए. हो सकता है अगर सर्कल बड़ा होता तो अमाउंट ज्यादा आ जाते, या सर्कमफ्रेंस छोटा होता तो रेडियाई कम आते. हो सकता है ना ऐसी चीज. आर यू गेटिंग दिस पॉइंट? m और m डैश होने सेम जरूरी तो नहीं है ना. Are you getting this point?
Yes, sir.
Right?
Yes.
So now, how you gonna get that m dash? Yes, tell me. See, what is the starting value of theta? Alpha. And what is the final value of theta? That is beta. So if your rotation is same, right? So that means your final value minus your starting value upon equal number of pieces is equal to the amount of each rotation. Is that right? समझ आ रहा है ना?
Yes,
यहाँ
sir.
पे क्या थे? m थे. यहाँ पे टोटल क्या था? a था. टोटल लेंथ a थी, तो a अपॉन r हो जाना था क्या? That is radius, right? The change in the radius at every point. So here what I'm saying is I have final rotation minus initial rotation upon number of times, right? And that is m dash. So of course b minus alpha upon m dash would be equal to the each number of rotation. Is it okay? यहां से भी देख सकते हो. Put the final value of theta, that is what? Beta. Beta is equal to alpha plus m dash delta theta. From here your delta theta is this. Yes, you are with me?
Yes, sir.
Now let's assume that, so let us mark the polar rectangles. Now why I'm calling it as polar rectangles? Because they are not rectangles, right? Can you see that yellow part?
Yes, sir.
Yes. Does it look like a rectangle?
No, sir.
No,
Why?
sir.
Why is it so?
Sir, curved.
Curved है. Yes. So that's why. यहाँ पे curve है ना. ये वाली
Yes,
साइड
sir.
तो स्टिल स्ट्रेट लाइन है, लेकिन ये वाली साइड ये तो कर्व है ना जो सर्कुलर के ऊपर ली जा रही है. सो दिस इज नॉट अ रेक्टेंगल, राइट? Is it
Yes,
okay?
sir.
This is sort of
Yes, sir.
sector, right? So I name it as polar rectangle. So why? Because they are not actually rectangles. So that's why So let us mark the polar rectangle. That's why I'm using the word polar rectangle over here. Okay, and mark the polar rectangles inside the region R and name it the areas, है ना? And name their areas as delta A1, delta A2, and so on up to delta A. Right? Are you with me? समझ आ गई ये चीज?
Yes, sir. Yes, sir.
अब देखो, अब क्या है, ये कुछ पोलर रेक्टेंगल बाहर भी जाएंगे, जैसे ये वाला देखो। तो ये वाला अगर तुम यहाँ पे देखो तो ये एरिया बाहर जा रहा है कि नहीं जा रहा है? इतना एरिया समझ आ रही है बात? क्योंकि रीजन हमारा एक्चुअल रीजन कहां से कहां के बीच में है? कैन एनीबॉडी टेल कहां से कहां के बीच में हमारा एक्चुअल रीजन? यस
Sir, it
Anybody?
goes between R equal to
yes,
G2.
R is equal to G1 theta and R is equal to G2 theta. So that is our region R. Right? So this is our region R. Is it okay? So that region R is actually lying between these two curves. Yes. You are with me?
Yes, sir.
Yes, sir.
तो कुछ एरिया बाहर भी जाएगा और कुछ एरिया अंदर भी आएगा, है ना? तो वो हमें फिर लास्ट में जाके क्या करना पड़ेगा? Theoretically what we'll do, we'll increase the number of polar rectangles so that exact area निकाला जा सके, exact volume निकाला जा सके, and so on. Yes, you are with me?
Yes,
समझ आ
sir.
रहा है? Okay, so now let's come to the next point. So these are the areas. So basically we mark them as, so this is something like, this is your delta A1, let's say this is your delta A2, this is the areas. So we are marking the area of this polar rectangle, right? This polar rectangle, and area of this polar rectangle is denoted as delta A1. Similarly, area of this polar rectangle is denoted as delta A2. Let's say we call this as delta AK. Then you know that in this sector your radius is, change of radius is delta R on both sides, right? Is it okay? Because from this circle to this circle we have the change of delta R. Yes, you are with me?
Yes, sir.
And what about the rotation from this point to this point, this point to this point? Kitni hai rotation?
Delta theta.
Delta theta.
Yes, delta theta. That is something which we know, that in every polar rectangle, the amount of rotation would be delta theta, and the amount of, let's say, ray or the change in the radius would be delta R. Yes. Are you with me?
Yes, sir.
Okay. So now let's come to the next point. Assume that RK theta K be the center of the polar rectangle, right? The polar rectangle with area delta AK, right? Is it okay? Yes, tell me. So what is the center over here in this particular rectangle? What would be the center? Can anybody tell
RK
me? What
theta
should be the
K.
center? Yes. So this is the center over here. Okay. So we call it as RK
Theta K.
theta K. And of course, its name is delta AK. I'm putting it aside, right? So that yellow marking is there, and I guess you know that. Okay, so we are talking about this. Yeah, is it fine? समझ आ रहा है ये चीज? Okay. Just a minute. So, what is the next point? Then the sum Sn is of the form, which form? Sn is equal to summation k runs from 1 to n f of rk theta k delta ak. And what is that? Can anybody tell me? ये चीज समझ आ रही है किसी को? ये कैसी चीज है? क्या ऐसी चीज डबल इंटीग्रल में देखी थी? टेल मी, क्या ऐसी चीज डबल इंटीग्रल में देखी थी कहीं?
वॉल्यूम के लिए।
वॉल्यूम के लिए। तो फर्क क्या आ रहा है? देखो फर्क ये आ रहा है क्योंकि हम पोलर की बात कर रहे हैं तो रीजन पोलर है, तो बेसिकली कैलकुलेट वही चीज कर रहे हैं, वॉल्यूम, लेकिन फर्क कहां पे आ रहा है? फर्क ऐसा आ रहा है, फर्क ये आ रहा है कि वही चीज है, और अब हम कर क्या रहे हैं? हम ऐसे कर रहे हैं कि वही हमारे सर्कुलर ठीक है, और वही हमारे रेज, ठीक है। और यहां पे क्या हो रहा है? यहां पे ऊपर कोई फंक्शन है जो कि ऑलरेडी पोलर फॉर्म में दे रखा है, ठीक है। सो इट्स जस्ट जस्ट अ काइंड ऑफ वे टू right. So this is your what? Can anybody tell me what is that point? Yes.
RK theta k.
Yes, RK theta k, right? And if you take the height at that point, right, and let's say this is your surface which is z is equal to f of RK theta k. So how you gonna get that volume of that pillar? समझ आ रही है ना चीज? तो पिछले डबल इंटीग्रल और इस डबल इंटीग्रल में व्हाट इज द डिफरेंस?
यस सर, पहले एक था,
पहले हाँ,
रेक्टेंगल थे।
पहले हमारा कार्टेशियन सिस्टम था, अब क्या है? पोलर सिस्टम है। तो चीज तो वही आ रही है। आर यू विद मी ऑन दिस? ओके,
Yes, sir.
so let's say if you want to calculate the whole volume, so what are you gonna do? As somebody has already pointed it out, so if f is continuous, right, on R, then the sum will approach. So as we take delta R goes to 0 and delta theta goes to 0, right? So we'll then write it as limit n tends to infinity Sn. So this will become double integral over some region R, which is with us. So this will become fr theta and this will become dA. Is it right? Yes. Is it right?
Yes.
Yes, sir.
Yes,
Right.
sir.
Now there is one more thing which is very interesting. Now just think about this thing. Just think about this yellow one. Okay. So let's say you want to calculate the area of this yellow part only. How are you going to get it? Let me make a line over here. Then you will find the things. So what I'm saying is I am making this line which is joined to the origin, right? Is it okay?
Yes.
Okay. Now
Yes.
tell me what is the value of radius over here? Yes. Anybody?
RK plus delta R by 2.
Yes, this will become RK plus delta R by 2, right? So if this is your point is RK, right? This point is RK, right? So this point will become what? RK plus delta R by 2.
Yes, sir.
And this point will become what?
RK minus
Minus delta R by 2,
2.
right? Now suppose you want to get this yellow area. So how are you going to do it? So you're going to calculate the area of whole sector, right? This whole sector, and this whole sector is what? So this is your whole sector up to here and here and here. So first you get the area of whole sector. Then what do you gonna do? You simply subtract the area of that lower sector. So if you subtract that area of lower sector, you will get the area of that yellow part, right? Which is no more yellow. Okay. You're with me? Tell
Yes,
me.
sir.
Yes, sir.
Okay. So how are you gonna calculate that area? Let's come to that part. Okay. So now the area of area delta K is equal to what? Area of larger sector minus area of small sector, right? So let me put it as large sector and small sector. RK minus delta R, RK plus delta R by 2 whole square into amount of rotation. Check कर लेना.
Yes,
ठीक
sir.
है?
Yes, sir.
So this is the area of the large sector minus area of the smaller sector, half RK minus delta R by 2 whole square into delta theta. Yes, you're with me? Tell me. Tell me.
Yes, yes, sir.
Yes, sir.
Okay. So now let's solve this. So if we solve this, this will become what? So we'll keep the delta theta by 2 outside. Yes. So this becomes delta theta by 2, and we have RK square plus delta R whole square. Delta R by 2 ka square, right? So delta R by 4 plus 2 times RK delta R by 2 minus RK square plus delta R whole square by 4 minus 2 RK delta R by 2. ठीक है? Okay? Yes.
Yes, sir.
Yes, sir.
तो ये कट गया अब, ये और ये भी, they'll also get cancelled out, and you are left with only 2 times the RK and delta R. So this 2 and 2 will also get cancelled, and you are left with delta theta, delta R, and RK. Yes, are you with me on this? Okay.
Yes.
So this was your, so look, just mark it as star. So now your star becomes what? Okay. So therefore star becomes what? Sn. K runs from 1 to n. F of R theta, sorry, RK theta K into, here you used to have delta K. And what was that delta K? Area of that sector, polar rectangle, right? So अब that delta K, area of delta K हमने already यहाँ पे निकाल लिया है. It becomes what? Delta theta delta R RK. Yes, you are with me?
Yes, sir.
ठीक है. तो अब अगर हम यहाँ पे फिबोनाची थ्योरम लिमिट वाली लगाएंगे तो ये क्या बन जाएगा? टेक लिमिट्स as n tends to infinity. So you are left with So let's say it was there f r theta dA. Now this will look like r f r theta. So instead of d theta, right, instead of dA, यहां जब dA था, अब dA की जगह क्या लिख सकते हैं? r d theta dr. Yes, you are with me? समझ आ रही है बात?
Yes, sir.
Yes, sir.
So basically, a more refined version will look like theta is equal to alpha to theta is equal to beta, and here r is equal to g1 theta to r is equal to g2 theta, and fr theta r dr d theta. Why dr first? That we have already discussed, because r is over there, that's why dr is over here. And if your theta is here, so that's why d theta is here. So what is the main difference? Can you anybody tell me that what is the main difference between the polar integral and polar version of that double integral and simple double integral which we used to have? See, at that time we used to write it as r fxy dx dy dA, and we used to write it as, let's say, x runs from a to b and y runs from g1x to g2x, right? So let me take this over here. Yes. So fxy dy and dx, of course, with for the known reason, because y is here, that's why dy is here, and x is here, that's why dx is here. So can you point out the major difference between these two? Tell me. क्या मेरी आवाज सुन
Presence
पा
of
रहे?
R.
Yes. Can anybody tell me? Yes, presence of R. That is the main difference. सिर्फ यही डिफरेंस समझाने के लिए मैंने इतना बड़ा आर्टिकल किया है, ठीक है? So basically, why that R appears over there? Because this time we are not working with the simple rectangles. We are working with these polar rectangles. So that's why this R will come into the picture. And instead of saying dr d theta, we'll write it as r dr d theta. Yes. Is it okay?
Yes, sir.